Here is a setup for conveyor belts or bike chains. First, make a curve, resample, apply some handy normals, and make sure the curve is an open-ended curve and not closed. Now, don't be scared, there will be some code. But don't worry, bear with me. I store the number of points I would like to have in a variable, which later will be the amount of sections on my conveyor belt or bike chain. The offset parameter ends up being the actual parameter to animate. I now loop through the amount set by my number of points parameter. So let's start from the bottom. By using the function addPoint, we add a point for the current iteration. Great, but where to put it? We put the point at a designated position. How do we calculate the position? We sample the position from our curve primitive. But that last part of the function states that we have to have a parametric UVW position to complete the function. This is not a regular UV coordinate, but a parametric coordinate dictating where on the primitive we are sampling. Since we don't have an area and only a curve, we only have a U coordinate and not a V coordinate. These coordinates go from 0 to 1. And so if I define 0.5, I will end up in the middle of the curve. Notice how we run into trouble if we have values such as 1.4. This is where the function frac comes into play. First, we have to create a U parameter by dividing the current iteration with the total number of iterations available plus an offset. This will yield numbers like 0.1, 0.2, 0.9, but due to us wanting to use an offset, we will have numbers like 1.4, 1.6, etc. The frac formula states that it will yield the fractional component of the floating point number. If you remove all your whole numbers and only look at what's after the comma sign, you will get your fractional component. This is useful to us because now the numbers provided by the U variable will always be fractional. Essentially, once we reach the number 1, it will reset to 0 and start over, giving us a looping behavior.